For over 50 years, we strove to capture the ever-shifting shapes and motions of the atmosphere, land, and ocean from space. The journey began with the Polar Orbiting Tyros series satellites, when a simple TV camera proved invaluable for detecting tropical cyclones at sea. It continued when the first camera, developed by Dr. V. Sumi of the University of Wisconsin, was launched aboard a geostationary communications satellite in 1966. Able to take a visible image of the Earth every 30 minutes, the ATS satellites quickly became indispensable in their ability to monitor the evolution of weather systems in real time. Soon, an operational satellite, fully devoted to monitoring the weather at geostationary altitude, led to the GOES series of satellites. They have been invaluable in detecting some of the great weather events of the past 40 years. Yet we always knew there were shortcomings in the ability of satellites to monitor the evolution of some of the worst weather on Earth.
East of 81, about a mile. I'm going to get ahead of it here, but you can see the point of it on the southwest. It's right here. Look at the right going in.
And thus we continue to strive to do better. A revolution in operational environmental satellites is underway that will lead to a vast improvement in our ability to monitor the Earth and its immediate environment. It begins with the launch of GOES-R.
Liftoff.
The next series of geostationary satellites, starting with GOES-R, is much more than a minor modification to the previous GOES 8 through 15 satellites.
This is like a brand new car. It's like trying to jump from a VW Bug to a DeLorean. You know, the technologies are so different and so much farther advanced. So you really are starting from a clean sheet of paper with every aspect of the system.
I am thrilled to see all the years of development finally coming to this cutting edge tool that we'll have. This is going to be a gold mine of new data across both hydrologists and meteorologists to help us do our jobs better.
This greatly improved observational capability will be able to monitor things as we've never seen them before. For example, seeing fires as they develop or hurricanes as they develop and move. So a number of phenomena will be better monitored with GOES-R, be it convection, smoke, fires, fog, SO2 associated with volcanic ash eruptions, etc.
The next generation of GOES provides the potential to produce a leap in benefits to society, from being better prepared for hazardous weather to floods and major geological events such as volcanic eruptions.
The biggest impact I believe the American public will see from the improved forecasts and warnings is the specificity of where the event is happening. The resolution of this information and will be able to help the forecaster pinpoint the onset, the timing of the event, and the exact location. And by being able to give that with such precision, the American public will know, hey, I've got to respond quickly.
The benefits of the new satellite series will be plentiful. The increase in spatial, temporal, and spectral resolution will help meteorologists issue severe weather warnings with more lead time. There'll also be improvements in forecasts for transportation, both on the ground and in the air.
The next generation GOES carries 3 major instruments, providing a suite of enhanced environmental monitoring. The instruments themselves have been completely rethought.
All of the instruments are different and much improved, and we've added a new one, a lightning mapper. The primary instrument has always been the imager. We've just taken that to a whole new level. We've tripled the number of channels in it. We've got 4 times the resolution, and we scan the Earth 5 times faster. So what we've got here is a system that on the ground is the equivalent of moving from black and white television to HD TV in terms of the resolution, what you can see with this. So it's a really exciting leap forward in what the forecaster will see and be able to use in their process, in the forecast process.
The ABI instrument has a scanning strategy that provides standard 5-minute scans for the primary viewing area. It provides 15-minute scans of the Western Hemisphere and 1-minute or better scans of 2 mesoscale sectors. The benefits from this are quite clear.
There'll be a lot of things that either we weren't able to see before or were difficult to tell with traditional satellite imagery. For instance, we'll be able to see sea breezes a little bit better than we used to. Another thing we'll be able to do is we'll be able to see the difference between low clouds and snow-covered ground, which in the past was very difficult. We'll also be able to look at several different layers of atmospheric water vapor, whereas in the past satellite series we could only look at one.
GOES-R and the GOES-R series will benefit society in a number of different ways. For example, seeing convection not only in its mature phases, but early on to give a better idea of what's going to happen.
The Geostationary Lightning Mapper, or GLM, is completely unprecedented for a geostationary satellite. Years of testing this instrument on polar orbiting satellites has made it ready for the GOES.
We'll be providing a lightning map where we'll show cloud-to-ground and cloud-to-cloud images of lightning. Researchers have shown that the intensity of those lightning strikes is an indication of severe storm and convection growing. It could give much more lead time toward tornadic warnings. It could identify the de-intensification or intensification of tropical storms. But it's going to take a very intense study of these new data sets to correlate them and understand how you can improve your forecasts and warnings.
Finally, the space weather community benefits from 3 near-space environmental sensors. These include the Space Environment In Situ Suite to measure the flux of energetic particles, the Extreme UV X-ray Irradiance Sensor to detect solar X-ray irradiance, and the Solar Extreme Ultraviolet Irradiance Instrument. These instruments will help detect solar events that could disrupt communications and degrade navigational accuracy. In addition, with the upgrade in communications and data processing, the imagery is available to everyone more quickly than ever before.
One forecaster told me, wow, the current system, Greg, is like showing me what has happened in the past. This new capability, the speed which you're getting to me, is like watching it unfold right now before my eyes. That's a dramatic improvement, and how you use that in forecasting is going to change.
The increased frequency and reduced latency means a change in paradigm for fast-evolving warning operations. In order to maximize the potential benefit of the next generation of GOES, forecasters, hydrologists, and other scientists will have to be prepared to use this new data resource to its full potential.
We have seen over and over again that when we introduce new technology into the forecast process, when we provide new data sources for the forecasters to use in their providing forecasts and warnings, that training is an important element in the use of that data. We saw that with the introduction of the radar data, the NextRad radar data in the 90s. The training was absolutely crucial to reap the benefits of that investment. We expect the same to be true for satellite systems, and especially for the GOES-R.
With the amount of data expected to come down from GOES-R and the number of direct applications it will have on observing atmospheric and land-based threats, it's vital that users are prepared with a solid understanding of all that will be available from GOES-R. Therefore, it's very important for forecasters to have a good grasp of the fundamentals of GOES-R.
Welcome to the Satellite Foundational course for GOES-R, or SatFC-G. The FC stands for the Foundational course, and it represents the cornerstone of GOES-R education for NWS forecasters and others. The Satellite Foundational course for GOES-R was created through a collaborative effort between NOAA and NASA and the GOES-R program. Several institutes, including the Cooperative Institutes for Meteorological Satellite Studies, for Climate and Satellites, Research in the Atmosphere, Mesoscale and Meteorological Systems, and then COMET was crucial in developing many lessons. Through the rest of this orientation, we'll give you objectives here, such as describe how this course will give students, that is you, readiness to utilize GOES-R in forecasting, describe the nature of the Satellite Foundational course for GOES-R, identify the course timeline and how much time is required to finish it, identify what is needed at each office in order to complete this course, and recall how to complete the course in the Commerce Learning Center, describe how this course will be facilitated, and finally identify help resources for you and facilitators. Besides this orientation, the course kicks off with a refresher on the basic principles of radiation. Produced by Comet, this lesson is designed to lift all boats to the same level in understanding basic remote sensing principles in order to be prepared to move on to the next lessons in the course. Then, upon having finished basic radiation, you will move on to another lesson authored by Sims and Nesdes, learning about the operations of the GOES. In this lesson, you will apply basic radiation principles to how the advanced baseline imager takes advantage of these concepts to deliver useful imagery. You will then proceed to learn more about the ABI, including its scanning strategy, bit depth, and accounting for parallax. Proceed next to a suite of 5 lessons on the spectral bands within the ABI. 2 lessons authored by Comet introduce you to the visible and near infrared bands. Then 2 more give you a tour of thermal infrared bands, including the water vapor channels. Then the ABI section finishes with a lesson on multi-channel interpretation, including an introduction to RGB imagery. This wraps up an introduction to the ABI, and next comes a set of 7 lessons on baseline products derived from the ABI. This section starts with a lesson on detecting aerosols, haze, smoke, and dust. A cloud and microphysics lesson follows, and then information on better fire characterization and land surface detection. This is followed by a lesson on improved rainfall and precipitation. 3 more lessons cover legacy atmospheric profiles, that is, stability and precipitable water. A lesson on derived motion follows. This is about the better derived motion wind vectors. And also a lesson on much better volcanic ash detection. The lessons in the introduction and the ABI are relevant to both meteorologists and hydrologists, whereas in the baseline products, hydrologists may find relevant lessons to be limited to clouds and microphysics, and the lesson on rainfall and precipitation. The course curricula reflect these lesson choices for meteorologists and hydrologists, in which I will expand upon soon. A final optional lesson on baseline products covers hurricane intensity estimates, or HIE. This lesson includes information on how it's created and how it's validated. And now on to the Geostationary Lightning Mapper, or GLM, where the first lesson is an introduction. Produced by Comet, this lesson describes the need for real-time lightning information and the capabilities of the GLM. You'll get a primer on the lightning flash cycle, differentiate how lightning is observed by space-based and ground-based detection systems, how a lightning flash product is created, and how it can benefit warnings. A follow-up GLM lesson produced by NASA Sport compares the GLM to other lightning networks and the display options available to the forecasters in AWIPS. These lessons may be most relevant to meteorologists, though anybody is welcome to take them. The next section of the course is all about interpreting mesoscale and synoptic meteorological phenomena. It kicks off with an introduction to the mesoscale, convective, and synoptic sections of the course, made for both hydrologists and meteorologists. The mesoscale convective portion encompasses 9 lessons on interpreting various phenomena ranging from pre-convective environments and monitoring convective storm severity of various types to polar lows and mountain waves. Meteorologists benefit from taking all of these lessons, while hydrologists have only the MCS lesson as a requirement. Then 7 lessons give you a tour of synoptic features that include topics such as atmospheric rivers, cyclogenesis, low-level jets, and upper tropospheric pattern analysis. Meteorologists take all the lessons as a requirement, while hydrologists take the lesson on atmospheric rivers. Capping off the lessons in the GOES-R foundational course is the section on numerical weather prediction, NWP. 2 lessons explain how satellites, specifically GOES-R, are expected to impact NWP. The GOES-R series offers an opportunity to improve data assimilation, including more motion vectors, lightning to highlight areas of latent heat release, and more frequent updates to legacy atmospheric profiles. These lessons offer you the opportunity to describe the impact of satellite observations in NWP, determine which satellite instruments have the biggest impact, and describe the processes of assimilating direct radiances. Another lesson teaches you how to compare simulated satellite imagery with the GOES observations. Both meteorologists and hydrologists have to take all lessons. In the Commerce Learning Center, or the CLC, you may find 2 curricula. The full course, intended for forecasters, is titled Satellite Foundational Course for GOES-R. It contains all of the sections we described, amounting to about 18 hours. Understand that the course length may be either shorter or longer for you. Each section in the CLC, from Introduction to NWP, has an end-of-section quiz. A shorter version of the course, called the Satellite Foundational Course for GOES-R Hydrology, takes about 9 hours to complete. This curriculum is intended for hydrologists. Okay, so you want to go ahead and find the course in the Commerce Learning Center, or the CLC. The fastest way to the courses in the CLC is to use the link provided here to go to the GOES-R Satellite Training Jump page. In fact, you can click on this link provided you are viewing this lesson in its own HTML page. You log in and you'll see a jump page with the links to the curricula like you see here in the middle column of the right table. There's also a tutorial in the jump page. And at this point, I would suggest that you take the tutorial before going onward. It shows you how to navigate through the CLC to take this course. You can pause this video as you see fit and then move on when you're ready to go. Let's say you click on one of those links in the jump page and you'll see the course introduction page. The standard curriculum, as you can see it here on the left, and the one for hydrologists as you see on the right. Here's where you can request the course. However, your facilitator may have already assigned it to you. Either way, the course appears on your transcript, and you may open the course and see a course description and then the contents of the curriculum. You'll see that each section has a completion bar and, more importantly, a button to view details for each lesson in the section. You select it and it brings up all the lessons in your chosen section. Simply launch the lesson using the button to the right of each lesson. The CLC recognizes that you've completed the lesson when you acknowledge that you've viewed the lesson. And the CLC will guide you through the lessons to be taken in the proper sequence. You will also be guided to the quizzes where they exist at the end of each major course section. So what do you do to take this course? First of all, you'll need to meet with your facilitator. Everyone in the NWS will have one. And as you meet your facilitator, you go ahead and choose your curriculum, whether you're going to go the meteorological or hydrological route. Then go ahead and plan an effective course of completion,
and you just move through the course in the CLC. The good thing is that the CLC will guide you along. As you take the course, you may have some questions that need an answer from one of the lesson developers, or you may have a CLC related question. For CLC questions, use the email address provided. This is lms.nws@noaa.gov. For other questions, go to the VLab Satellite Training and Operations Resources page, or you can call it the store community. You do this by going into the VLab via your NOAA email account. Then you go ahead and go to community. It's an option that's on the left side of the display. You click on it and then go ahead and type store in the search bar in the upper right. Pick the top hit from the results and you're in. Now once you're in there, the store page contains a wide variety of information ranging from operational aids, quick training, AWIPS items, current mesosector locations, and more. In the quick training tab, it gives you quick guides, quick briefs, job aids, and application matrices that describe the GOES products and their uses. More items will be added here soon. Let's go ahead and recap what I said for this orientation. First of all, your readiness to use GOES-R data is achieved through taking 7 sections of this course. And as a student, you'll need to have internet access so that you can play the online lessons. You will have them in sequence. You'll need about 18 hours to complete the course, 9 for the hydrology track. As far as the lessons are concerned, you'll need to complete each one individually online, and then there'll be quizzes in the Commerce Learning Center. Passing is 70%, though retakes are allowed. You'll have help resources. First of all, there's an email that can reach all the course producers. That is lms.nws@noaa.gov. There's also a site here called the VLab store site, and that one has lots of information, including quick guides at your disposal. I hope you enjoy this course and be able to make good use of what you've learned in your environment. If there is one last poignant comment, it would be that the GOES-R series will make students of us all as we see phenomenon in a new capacity.